So there's a difference between a normal distribution and what we are going to be calling the standard normal distribution. So for example, let's say we collected some data, and then that data has variables, and then we graph those variables. So we end up with a distribution kind of like this one, the green one, where the range of the data is going from 950 to 1070. We don't really know what it means. We don't really know what the variable was. But we know when we graph that data set, it looks like a normal distribution. When we actually plot a histogram for it, it looks like a normal distribution. So what we are going to do is that we are going to use the z-score. That's our formula. We're going to use the z-score to standardize that data set. Once we standardize it, it's going to become what we call the standard normal distribution. You can see that the shape doesn't change a whole lot, but what's going to change is that the mean, I need a different color here, the mean is always going to be 0, and the standard deviation for that population is going to be 1. So the one characteristic of the standard normal distribution is that the mean is 0 and the standard deviation is 1. And now that we have everything in terms of z-scores, it's going to be easier for us to know where a certain score was. Like, for example, I'm going to know easily that a score of 10,030 is 1 standard deviation above the mean. And so on, like, because I already transform all of my scores into z-scores, it just makes it easier for me to find any other score, the position of any score in that data set. This is particularly useful when you have variables that are on different metrics and you want to do analysis. What you do is you transform them into z-scores, and now everything is on the same metric and you can use them in your analysis. So what we need to remember about the standard normal distribution? Well, we need to remember that the mean is 0, the standard deviation is 1, the area under the curve is 1, or 100% is 1. So the total area here and here would be 1, or 100% if you want to. Because it's an area, it can never be negative. If one day you end up with a negative area, I would go back and check what happened, because it's just not possible. Another thing you need to remember, and you probably already know this because I've mentioned it before, everything to this side of the mean is going to be 50% of the distribution. Everything to this side of the mean is going to be 50% of the distribution. If we're talking about area, then on this side it would be 0.500, and on this side it would be 0.500. Another thing you need to remember is that z-scores can be positive, and if they're positive, they're going to be to the right of that distribution, and if they're negative, they're going to be to the left of the distribution. So z-scores can be positive or negative. Obviously, if they are negative, they are indicating a position that is below the mean. If they are positive, they're indicating a position above the mean. So the last thing that I'm sure you already know, but I want to point out, is that the standard normal distribution is symmetric. And we know that from here. We know that to this side there's 50%, and we know for this side is 50%. So if I have a z-score of +1, it's going to be the same distance from the mean to that +1 as it is from the distance from the mean to the -1. So just what you really need to remember is that the curve is symmetrical.